Aloha champions, and welcome back to our science corner. So today we're finishing up Unit 2, Chapter 6. This is the last chapter in our unit. So on Thursday, instead of moving into Unit 3, on Thursday I'll be introducing our STEM project for this week. And you'll have Thursday and Friday to work on it, maybe the weekend if you absolutely need it. But we'll be doing a project that focuses on energy and waves, the two topics that we've covered so far in science over the last 2 units. So look forward to that STEM project on Thursday. But without further ado, we are currently here on Chapter 6, Using Signals. So before we get too far in, our big question that we want to answer is, how are waves, the form of energy, used to send signals? Okay, 2 vocabulary terms that we have on this first page. We have transfer, which is to move from one place to another, and we have the term information, types of data such as pictures, sounds, and messages. So let's get into Chapter 6, Using Signals. Chapter 6, Using Signals. People listen to music on a radio when they ride in a car, or they watch TV when they're at home. But how do these devices work? Well, both a car radio and a TV receive a signal that has been broadcast. To broadcast means to transmit or transfer a signal in some form of a wave. Broadcast stations such as radio and television stations send signals in the form of waves to receivers in TVs and radios. The signals transmit information such as symbols, pictures, and sounds, and often they do so in the form of waves, whether they're light waves or sound waves or a combination of both. Broadcasting devices use technology to change sounds or pictures to signals in the form of waves. These wave signals are broadcast in a unique pattern. The pattern is sent as a wave from one device to another. That device transforms the wave signal back to sounds or picture. What is analog information? Vocabulary term for this page is analog. Analog is describing signals sent as continuous waves. So sent constantly from one transmitter to a receiver. There are 2 ways to send information in a wave signal. You can use analog signals or digital signals. Analog signals send information using a continuous flow of electrical energy. Patterns of electrical energy travel as a continuous wave, whose pattern varies as it travels through the atmosphere or through electrical devices. An old-style phonograph or a record turntable uses an analog signal when the needle moves up and down on the record to create a flow of electrical energy. That energy powers speakers, and we hear the recording from the record. Maybe I'll do a video on records because I have quite a few records, and looking at my turntable is always a fun time. But I digress. TV broadcasts once used analog signals to send and receive information in the form of radio waves through the atmosphere. Most radio broadcasts still do. Radio is still mostly analog. Sometimes it's digital, especially if you have XM or Sirius satellite radio, but most of your AM, FM radio stations are analog. It's a continuous wave of electrical energy. These are analog signals because they are a continuous flow of wave energy. So here's an example of broadcast towers that send the digital and analog signals across large areas. If you ever look up at South Mountain, just beyond Paideia, you'll see all the towers up top. At night, it glows red and white to show us those are the towers. Those are all our broadcast towers for radio or television up on that mountain. So now we're on to what is digital information. Our vocabulary term is digital. It describes signals sent as separate bits and it is not continuous. So smaller chunks of information is sent out in digital. An analog signal is always a continuous flow of information. The other way that signals can be sent is by using digital signals. A digit means a number. Digital communication turns information into number patterns. Information sent by digital signals is not continuous. It is broken down into digits or millions of individual bits of information. Digital signals exist in discrete bits and are often only include the numbers 0 and 1. Information is thus broken into a pattern and is a code. This code can be sent with or without wires. With a digital signal, information can be sent anywhere. Your tablets, your computers, and your cell phones use digital signals to send and receive information. In common computers, digital signals are coded in patterns. For example, 01000001 represents the letter A. It would take a lot of zeros and ones to write your name on your paper using this code. Digital signals, however, can be recorded onto CDs, DVDs, Blu-ray discs, and any game cartridge that you have. Those are all digital signals. So if we compare digital signals, we might have, if we see the wave, we might see that it's very jagged. 1, 0, 1, 0, 1, 0. An analog signal looks like a more traditional wave, where we can see the crest and the trough as it goes up the waveform, and we can measure the wavelengths. We can still measure the wavelengths of a digital signal. It's just much more jagged than a smoother wave, okay? So cell phones. Cell phones use wave signals to transfer information. Imagine using a phone to send a text message. You type the message and press send. Then your friend gets that message. But what is really happening? Cell phones use digital signals to send messages. A cell phone turns your message into a digital pattern of zeros and ones. So here we have your cell phone sending out a message. The cell phone uses a digital signal to change a message into a pattern of zeros and ones, or binary code, because it only has two numbers, 0 and 1. 0 is off, 1 is on, and combination makes the letters. The pattern is sent in radio waves to a cell phone tower. So from your phone, you send the message. It's encoded as a bunch of zeros and ones, 01, 01, 0001, 01, 0110, and so forth as we carry through. Then it's transferred to a broadcast tower, whether it's up on South Mountain or one of those fake looking palm trees that has all this information. And from there, the cell phone then sends this digital signal by radio waves to a cell phone tower. So back and forth from radio tower to radio tower, the cell phone tower passes the message on by sending the signal to another tower or directly to your friend's cell phone, depending on how close you are. Sometimes it has to go to the tower, up to space, and back down. Other times it could just be pounced from tower to tower. Your friend's phone then receives the code and changes that pattern of numbers back into a text message that your friend can see. So passing from tower to tower, it relays your signal. It's still a bunch of ones and zeros, same set of ones and zeros, the exact digital information we started with, to your friend's cell phone. And the cell phone receiving the signal changes the pattern back to a message, so they can open it up and say, hey, they got a message, okay? Another type of technology that uses signals to transfer information is GPS. GPS uses wave signals to transfer information. GPS stands for Global Positioning System. You may have used a GPS device or an app when traveling or playing a game. GPS can help people find their location or figure out where some other location is. The system began as a tool for people in the military to know exactly where they were when they were in very remote or hidden places. But now it's used by people everywhere. Suppose you wanted to know your exact location on Earth. Well, how can the GPS app in your cell phone do that? Well, a device such as a cell phone broadcasts the signals of radio waves to 3 different satellites. So satellite 1, satellite 2, satellite 3. Your information's going all over the places. Okay? The satellites then return the radio wave signals back to your cell phone. Your cell phone measures how long it took the waves to measure to and from the 3 different satellites, or it triangulates your position. It then performs calculations to determine your exact location. Notice that the signal is a simple one. It is a radio wave. Do you want to know how far away the nearest gas station is? Do you want to know how far it is from school? Do you want to know where to find a good fishing or camping spot? Well, you can find out by using GPS, using radio waves up to satellites back to you to tell you where your exact position is and where the position of your desired thing is. Okay? Fiber optics use wave signals to transfer information. Okay? Fiber optics is a process of transferring information via light waves using a special cable. Light travels in waves along bundles of thin, flexible glass fibers. The fibers are bundled inside the cable. If you have ever used cable TV, you have used fiber optics. Or if you've ever used internet, you've probably used fiber optics before it becomes Wi-Fi. So how are light waves used to send signals in a fiber optic cable? Well, first, a transmitter changes the information, such as a recording of your favorite TV show, to a digital code, a whole bunch of zeros and ones. The code is then transformed from numbers to flashes of light. The light waves enter one end of the cable. The cable is special. It allows the light to move freely through it without disrupting the wave pattern. The other end of the cable is attached to a receiver. The receiver receives the light waves and translates them back to an electronic digital signal. Finally, the electronic signal is translated back to information the device can understand. You can then watch your favorite TV show. So here's an example of fiber optic cable. Fibers inside the cable carry light waves, which can then be transformed to information your device can understand. If you remember a few weeks ago, before we went on fall break, many of us had internet problems. Well, that's because our internet provider, Cox, was replacing these fiber optic cables. And when they were replacing them, it took the internet out because our internet travels across long distances through light waves. And so using these cables, using light waves, and remembering how much faster light moves than sound, you can see how this can transfer a lot of information a lot quicker than your radio waves would from cell phone to cell phone or cell phone to GPS system. But with that, we are now at the end of Unit 2 for science. We've talked about energy, we've talked about waves. Using what we learned from this chapter today, answer the 5 to 10 questions that I have on Google Classroom. On Thursday, we're going to begin our STEM project, and we're going to look back at some of the topics we covered in chapters 1, or Unit 1 and Unit 2. Everything we've done since we've started school, looking back at science, and compiling it into a fun project for you to do. So look forward to that on Thursday. With that being said, I hope you stay awesome, and I will talk to you real soon.